Okay, so we're asked to evaluate this limit by using a Maclaurin series because it's centered at x equals 0. So to do that, you could first think about the Maclaurin series for cosine of x. So if you were to do that, and if you can figure it out, then you could just plug in 4 times square root of x everywhere where you see an x into the Maclaurin series. So if we find the Maclaurin series of cosine of x, when n is 0, that means the function without a derivative. We plug 0 into that function, then we divide by 0 factorial times x minus 0 to the 0 power. And it's plus the first derivative, so the derivative of cosine is negative sine, centered at 0. So this is now the first derivative, so that's x to the first power. Then plus the derivative of negative sine is negative cosine. Plug 0 in there. This is to the second power because it's the second derivative. And then what do we get next? The derivative of negative cosine is positive sine. It's centered at 0 over 3 factorial because we just did the third derivative. Derivative of sine is cosine. 4 factorial. This is x to the fourth. A lot of these are going to be 0. That's why I keep expanding. Derivative of cosine is negative sine. 5 factorial x to the fifth. And the derivative of negative sine is negative cosine. 0. 6 factorial x to the sixth. And then maybe one more for good measure. The derivative of negative cosine is sine 0 over 7 factorial x to the seventh. And that's probably enough to see the pattern. So this whole term, this is cosine of 0 is 1. 1 divided by 1 is 1. X to the 0 is 1. So this is going to be 1 for the first term. Sine of 0 is 0. So this whole term is 0. This is negative 1 in the numerator. So that's negative 1/2 x squared for this term. Sine of 0 is 0. So that whole thing is going to be 0. This is now positive 1 over 4 times 3 is 12. 12 times 3 is 24. X to the fourth. This is also 0. This is now negative 1 over 6 factorial, so negative 1 over 6 factorial. Oh, I hit 32 on x and 6 times 5 times 4 times 3 times 2. So that's 720. X to the 6. Okay, so that's what cosine of x is. So that means the Maclaurin series for cosine of 4 square roots of x is going to be 1 minus 1 over 2, this term squared. So that's going to be 16x. And then this is going to be 1 over 24 times this term to the fourth power. So 4 to the fourth power, that's 256. And then square root of x to the fourth power is x squared, because powers on top of powers multiply. And then we got another subtraction. This is going to be 4 to the sixth power. So 4096. I'll put that on top of the fraction. And now we're not plugging in x here. This is 4 square roots of x to the sixth power. So that's going to make x to the third. So here's the Maclaurin series for this part over here. Okay, so remember what a Maclaurin series does for us is it approximates a function. We could keep going obviously with that function, but this is approximately equal to the limit, as x approaches 0 of 1 minus, this is going to be 8x. Simplify, and I'm sure 256 divided by 24. Oh, no, that doesn't work. So 256 divided by 12? No, 256 divided by what else? 8? Yeah, okay, so we got 32 up top and 3 on bottom. That's x squared. And then here, 40, I don't want to simplify that one. 4096 over 720 x to the third. And then there's more terms if we keep going. So with a little bit of rewriting, we've got 1 minus 1 makes 0. And then you're changing all the signs because you're distributing a negative sign. So that's 8x plus 32 over 3x squared minus this big fraction, x to the third. Okay, I got lazy, I didn't write that fraction. But the whole point is that with the Maclaurin series, it keeps going, but eventually every term is going to have an x. So you can factor at least one x out of everything. So factor an x out of the numerator. So that makes 1, that makes this to the second, and the x's cancel out in the denominator. So now you're going to have the limit as x approaches 0 of 8 plus 32 over 3x minus some big fraction times x squared. We can evaluate this limit. We made the x's cancel. So the Taylor series, the Maclaurin series, helped us simplify. Now we can say this limit is definitely going to be 8. Before, we couldn't do that in calculus because we had a divide by 0 problem if we tried to substitute 0. Now we can conclusively say this limit is going to be 8.